When we looked at for loops, we said they iterate over a sequence of elements. One of the examples we checked out was iterating over a list. Let's take a little trip to the zoo to see this in action. Okay, so we will make a list of animals. So animals equals, and since we're making a list, we'll start with a bracket. And we'll add lion, zebra, dolphin, and monkey. And end the list with another bracket. Chars equals 0. And we'll start a loop. For animal in animals, 2 spaces, chars, plus equals length of animals. Print total characters average length dot format chars length animals. In this code, we're iterating over a list of strings. For each of the strings, we get its length and add it to the total amount of characters. At the end, we print the total and the average, which we get by dividing the total by the length of the list. You can see we're using the len function twice, once to get the length of the string, and then again to get the amount of elements in the list. What if you wanted to know the index of an element while going through the list? You could use the range function and then use indexing to access the elements at the index that range returned. You could use a range function and then use indexing to access the elements at the index that range just returned. Or you could just use the enumerate function. Winners equals, we'll make a list, Ashley, Dylan, and Reese, and close the list. For index, person in, enumerate, winners, print, curly brackets, dash, curly brackets, dot, format, index, plus 1, person. The enumerate function returns a tuple for each element in the list. The first value in the tuple is the index of the element in the sequence. The second value in the tuple is the element in the sequence. You're the real winner with the enumerate function. It does all the work for you. Pretty useful, right? Let's use all of this now to solve a slightly more interesting problem. Say you have a list of tuples containing 2 strings each. The first string is an email address, and the second is the full name of the person with that email address. You want to write a function that creates a new list containing 1 string per person, including their name and the email address between angled brackets, the format usually used in emails, like this. So, what do we need to do? We'll start by defining a function that receives a list of people. Def full emails takes the argument people. Remember, people is a list of tuples where the first element is the email address and the second one is the full name. So in our function, we'll first create the variable that we'll use as a return value, which will be a list, and we'll call it result. Result equals empty list. We'll then iterate over the list of people. We know this list contains tuples of 2 strings each, so we'll unpack the values directly when iterating in variables that we'll call email and name. For email and name in people, Now our result variable is a list, and it should contain strings. So we'll append the resulting string to the results list. Result.append. The string that we'll append will be formatted in the way we want. To do that, we'll use the format method with the two variables of our iteration. So curly brackets, dot format, name, and email. Once we're done with the iteration, we'll return the list, which should now contain all the necessary emails. Return result. Will this work? What do you think? Let's try it out. Print full emails. alex@example.com. Alex Diego. Shay@example.com is the email, and we'll call Shay Brand as the name. Yes, this worked as expected. Before we move on, a quick word of caution about some common errors when dealing with lists in Python. Because we use the range function so much with for loops, you might be tempted to use it for iterating over indexes of a list, and then to access the elements through indexing. You could be particularly inclined to do this if you're used to other programming languages before. Because in some languages, the only way to access an element of a list is by using indexes. Real talk. This works, but looks ugly. It's more idiomatic in Python to iterate through the elements of the list directly, or using enumerate when you need the indexes, like we've done so far. There are some specific cases that do require us to iterate over the indexes. For example, when we're trying to modify the elements of the list we're iterating. By the way, if you're iterating through a list and you want to modify it at the same time, you need to be very careful. If you remove elements from the list while iterating, you're likely to end up with an unexpected result. In this case, it might be better to use a copy of the list instead. We've now seen a bunch of different things we can do with lists, and hopefully you're starting to see how they can be a very powerful tool in your IT specialist toolkit. Next up, we're going to learn a powerful technique for creating lists.